delicious. Oh, no. Okay, let's continue. I want to try to get through the lesson before somebody has to leave. Oh, yeah, you. Okay, so we'll start off with.
Hey, somebody.
Okay. So I know you know what a rectangle is. Right? We've seen a rectangle, but the actual definition is a quadrilateral with 4 right angles. Now, does that make a rectangle a parallelogram? Yes, it's a special kind of parallelogram. Right? So, do all the properties of parallelograms apply to rectangles? Like, are the opposite angles congruent? Yes. Are consecutive angles supplementary? Yes. But are opposite sides congruent? Yes. And do the diagonals bisect each other? Yes.
But I have a question, like.
If you do diagonal line, it bisects the other.
Right?
Oh yeah, because like a supplementary thing also works. Because, like,
right? So these two would be congruent. And we're going to learn another theorem. Technically. Okay, if we can't stop ourselves from talking.
No, we're stopping now.
Okay. No. Only in parallelograms. Specifically when I'm talking about quadrilaterals, only parallelograms have diagonals that bisect each other. Okay. Trapezoid? Yeah. Trapezoids, they do not bisect each other. Okay, I promise. I wouldn't tell you that if it wasn't true.
Wait, what did you? Why did you do lines on all the page? You have to do 2 lines on one.
Huh? Where? Yes, so we're actually going to learn a little bit more about rectangles. So technically, yes, you're right. Like normally we would have, these two are congruent and these two are congruent. Now what we're going to notice, in a parallelogram, like traditionally speaking, it's like a slanted rectangle, right? Which ends up stretching the one diagonal longer. But what do we notice about a rectangle? It's standing like upright. So what ends up happening is the diagonals of the rectangle will be congruent. So like I said, let me go through these first. So again, a rectangle is a parallelogram. Right? So again, what are the properties? Opposite sides are congruent. Opposite angles are congruent. Do we know? Oh, also, what about are the opposite sides parallel?
Yes.
Yeah. Opposite sides are parallel and diagonals bisect each other.
Can't be,
Oh, I also didn't put in the other one, but it's self-explanatory, right?
Which other one?
Consecutive angles are supplementary. So all the rules that apply to parallelograms also apply to rectangles.
Supplementary.
The additional piece is that we have 4 right angles. Right? Again, this is the definition. And then we have one additional theorem, and that is the diagonals are actually congruent. Remember how I was just talking about that? With a parallelogram, one diagonal ends up being longer because it's like stretched out, right? Whereas here, they're exactly the same length, which means if we combine the fact that they bisect each other and they're congruent, what we end up with, all 4 parts of those diagonals are identical. So if you know one length, right? If this was 3, this is 3, this is 3, this is 3. And what kind of triangles do you see here? Isosceles. We have isosceles triangles here and at the top and the bottom. Okay?
2 sides of the.
Right. Okay. So we have quadrilateral. ABCD is a rectangle. AC. So AC, this whole thing, is 30 minus x. And BD is 4x minus 60. Find the value of
Set them
x.
equal to each other.
Yeah, because what was that last theorem that we did? We said diagonals are congruent. So
Only in a rectangle, though.
only in a rectangle, not necessarily. Okay, so here I would add x, add 60, so 90 equals 5x, and Max, you said
Hi, Leo. I miss you.
all right. So we said 18?
Did you go 35?
Oh, Max is jumping ahead here. Let's see. NR is 2x plus 10, and NP, just that portion,
So you have to
is
divide it by
2x
two.
minus.
But then this is gonna become x is
So you would find x
no,
and
just
then
find x and then plug it in
and
and
then
then
plug
divide
it
it by 2.
for the NP.
No, you have to
Plug in
divide
the
it by
x
two.
for the.
Oh, hold on. Okay, what do we know about these two segments?
30.
They're equal to each other, right? And if NP is 2x minus 30, isn't this also 2x minus 30?
Yeah.
And then the whole thing is 2x plus 10. So we need to come up with an equation.
2x.
So you have
I have
2x
one.
plus
Yeah.
2x plus 30 times 2
Okay,
times 2 equals 2x plus 10.
perfect. Right? So we could just double. Now, Max, you were saying something about dividing in by
Yeah.
2. You could, if you divided this whole thing,
Yeah.
2x plus 10
I
by
did x
2,
plus 5.
you could do x plus 5 equals to 2x minus
that's
30, and we should get the same answer. So let's see.
X equals negative 50. X equals negative 25.
Wait a minute, not negative though.
Positive
I got
30.
negative.
Hold on, 2x equals, I get 70, because if I subtract 2x from both sides,
Right?
Positive
and then
30.
add 60,
I subtracted 60 because it's 30 times 2.
but it's a minus
It's
30.
positive 60.
Yeah, I
It's a
got my
minus
10.
30, so you have to
Oh,
add,
shit. Oh.
right, opposite. Okay, so divide both sides by
So x equals 35.
x
Yeah, that's what I
equals
got.
35. Now, go back, and what are we looking for? It says find MP. So,
So we would plug it back.
okay, so MP, I don't have any information for, but however, what did I say about all 4 of those segments in a rectangle? They're all the
So
same.
you just plug the 2 times 35.
35, so that would be
2 times 35. Right, so we could plug it into,
Wait, I'm using my phone.
So it's
40?
40, yeah.
wait a minute. Oh, yeah, 70 minus 30. So we get MP is 40.
I got 80. Oh, I did wrong. I did wrong.
Okay.
Oh,
Oh, yeah.
Sorry.
No,
Lovely.
8 is a strong word.
Okay, another rectangle. Find the values of x and y.
Getting a negative one.
okay, you can do
Wait.
4x plus 5 plus y2 minus 1 equals 180.
Why?
Why
I
do we
mean,
get
no,
180?
you can do y squared minus 1 equals 4. I got a negative number.
Yeah.
What'd you say?
Okay, these two are alternate interior angles. Remember, all the properties of parallelograms apply. So y squared minus 1 has to equal 4y plus 4. This is a quadratic.
You have to
What do you mean y?
root it by whatever.
Okay, let's move everything to one side. So I'm going to subtract 4y,
y2 plus 5.
and I'm going to subtract 4. So I get y squared minus 4y minus 5. Okay, so when we have a quadratic, we want to either do factoring or quadratic formula. This one does factor.
I don't remember. I mean, do you remember this? What is it mean? Oh my god. It's about 100. I know.
Okay, this one is pretty easy to factor because there's only 2 things that multiply together to give us,
Or 2. Wait.
no, multiply together to give us 5. So that would just be 1 and 5.
Remember our partner factoring quiz last year? Remember it?
I don't.
We got
No.
100. Sienna and I were partnered.
Okay,
and we got
now,
100.
one of them has to be positive, one has to be negative. I need to make sure when I add these, I get a -4.
Let's make the 5
Make the 5
positive. Negative, because it's positive.
negative, and this has to be positive. Again, I have to be able to combine these to give us the middle coefficient and multiply to give us the last one.
Wait, why do you have 1 and 5?
Because 5
I don't understand what
plus
the-
-1 is
Okay.
-4. and-
If you don't remember factoring, which was part of Algebra 1, that's a come to bonus moment.
Can I just say 2 minutes after class? So you can-
Well, factoring takes a little more than 2 minutes.
Algebra 1 lesson.
Oh no, wait, you have to do
Oh,
that.
and then you just get I just need like a belt.
Actually, hold on. Okay.
Wait, but where did you
Wait.
get the 1 and the 5? Because it's what adds and multiplies.
I
Is
just
this whole
explained
lesson factor?
Okay. One of these answers does not make sense if I try to plug it back in. The -1. Because if I tried to plug this back in, 4 times -1 would be -4.
It would just
Plus,
cancel.
that would make it 0 degrees, so that doesn't make sense. So y is just equal to 5. Okay, now we got to solve for x.
Yeah.
Yes.
They are complementary because it says a rectangle. So 9x plus 20.
Why are they complementary?
Oh, I think they equal each other.
They
Plus 4x
they
plus
don't
5.
necessarily. Okay, phones.
But I don't understand why it's complementary.
Because there's 4 right angles, and that line bisects the angle.
Just because they're next to each other.
Okay.
Yeah, they're next to each other and they make a right angle. Okay, so 13x equals 65.
Probably doesn't go in.
It does. It's 5. If it didn't go evenly, we would just circle 65 over 13 and just leave it like that.
So,
Yeah, so the next chapter is wrong. What?
it's wrong.
Rhombi. Okay.
Measure angle 1 is
Okay, so all we know in this whole figure is angle 1 is 40. Now we also know that they're
Like
right
vertical
angles.
Okay, so 2 is 50.
Okay,
2 is 50.
all right, so let's see. Let's just go and label everything and then we'll write in the answers. So if this is 40,
alternate,
2 is
and then-
50.
And then 6 is the alternate, whatever, so that's 40.
40, good.
And then it's probably 50 on the, oh wait, no.
Okay, what do we know about all the segments that make up the diagonals?
They're all
There you
equal.
Okay, they're all equal. So what do we know about the base angles in an isosceles triangle?
So they're the same.
Okay, so if we're looking at this triangle, you see how these two sides are congruent? What would be the
I
base
get it.
angles?
Okay, so 3 is 50.
2 and 3 have to be the same. Those are, right, we kind of have to look at it like sideways. Do you see
50,
it?
100. So then 4 is 80.
So, right, that makes this 80.
7 is 100.
7 is 100.
Oh yeah.
That means 8 is 50.
That means 8 is 50. And we just need angle
Wait,
5,
how'd you get 8 to be 5 is 40?
Yeah, okay.
40.
Because it's alternate.
Do we have to write the things in there?
I mean, it's your notes. I'll just write them in. 40, 50. Angle 3 was 50. 4 is 80. Did you have a question, Mia, on one of them?
Me? Yeah, it was y is 8.
Because 3 and 8 are alternate interior angles. Do you see that?
Oh, right. And then how is 7 100?
Because 180 is linear pair, so 4 and 7 are linear pairs.
Wait, too fast.
Linear pair. What do we know about a linear pair? They add up to
180.
180. So if this is 80, this has to be. Okay. All right, this is just the converse of the previous one. So if the diagonals of a parallelogram are congruent, then it has to be a rectangle. So if I give you a parallelogram and I say the diagonals are congruent, that makes it a rectangle.
All 4 diagonals are.
So if it says that,
So-
it has to be a.
Yeah. So
all
even
of the diagonals are congruent. All 4
right.
of
So
them?
like if I give you oh, here, this is a parallelogram. Now, when I draw it like that, one diagonal ends up being longer than the other. But if I gave you, I said this is a parallelogram, and this diagonal are congruent, then we automatically know it's a rectangle.
What if it looks like the top one, but they say it's
If they say they're equal, then that makes it a rectangle, even if it doesn't look that way. Okay, last example. So, let's graph -4, -1. So here's D. -2, -5 is F. 4, -2 is G. And 2, 2 is H. We want to see if this,
Oh, distance formula?
okay, so,
Or slope? Did we not say midpoint?
okay, midpoint will only tell us if we have what? That will tell us if the diagonals bisect each other, which that will tell us if we have a parallelogram. But rectangle, there's a couple of things we could do. We could do slope. What do we need for right angles? We need perpendicular lines. What would the slopes have to be if they're opposite reciprocal? But what did we just say above? If the diagonals are congruent. So if I just check, see, if I do slope, I have to do slope 4 times. But distance, I would only have to do twice. So let's remind ourselves, distance is square root x2 minus x1 squared, y2 minus y1 squared.
I don't want to. Can we do slope?
Yeah, but then you have to do it 4 times. This way you only have to do HF, and then we'll check DG.
So it has to be the reciprocal.
Oh no, I'm doing DF. And then G. Is that fine?
Well, that you have to do slope.
Oh, you have to do find the diagonal.
Wait, but
I'm finding the diagonals. That's why I'm using this one.
Oh.
Okay, so H is 2, 2. F is -2, -5. So I'll have 2 minus -2. So that'll make it 2 plus 2 squared.
We would ask how you do.
And then 2 minus -5, that becomes 2 plus 5
so
squared.
-2 minus
It doesn't matter because when we square it, we're going to have 4 squared is 16. 2 plus 5 is 7. 7 squared is 49. 16 plus 49 is 65. And that doesn't reduce. So now we want to see if we get the same answer for DG.
So if it's not the same answer,
Then it's not a rectangle. So I'm going to highlight this here. So I have 4 minus -4, so that 4 plus 4 squared. And then -2 minus -1. Okay, so I get 4 plus 4, that gives us 8 squared is 64. And then -2 plus 1 is,
It's just one.
it's just 1. Yay, we got that they're congruent. So, yes, DFGH is a rectangle.
Can I just write yes?
Yeah, you can write just yes.